Welcome to this class of artificial intelligence where we are discussing fuzzy systems and fuzzy logic. Now we will discuss fuzzy relations and take some examples to understand this. So we need to see that what we mean by fuzzy relations. So fuzzy relation is going to map elements of one universe, say X, to those of another universe, say Y. And this is done through Cartesian product. Of two universes X and Y. However, the strength of the relation between ordered pairs for ordered pairs of elements from X and Y. Suppose we take x1, y1, x1, y2. These are ordered pairs. y3, x2, y1, x2, y2, x2, y3. We are assuming that here we have in X we have x1 and x2, these two elements, and here we have y1, y2 and y3, three elements. Then the ordered pairs which are possible from these are all these ordered pairs. So for all these ordered pairs, we need to specify the relation between these two elements, and that relation can be specified with the help of in terms of a strength, and this value of a strength is going to be in the range 0 to 1. So we will be assigning some value between 0 to 1 for this ordered pair. Similarly, for this ordered pair, some value between 0 to 1, and so on can be done for all these ordered pairs. So here this strength of the relation between ordered pairs of the two universes X and Y is not measured with the characteristic function as it is done in case of crisp set, rather with a membership function. So these values we are getting with the help of a membership function which expresses various degrees of strength. So we have various degrees of strength of the relationship on this interval, unit interval 0 to 1. And so fuzzy relation, now fuzzy relation also we will be using with tilde and stripe. This fuzzy relation R is a mapping from Cartesian space, as we have seen above, Cartesian space, which is X cross Y to this interval 0, 1, where the strength of the mapping is expressed by a membership function of the relation for the ordered pair from the two universes like this, and this we will be representing as UR X, Y. Now we will take an example that for this fuzzy relation. So suppose we have two fuzzy sets. One is A tilde It is defined on a universe of three discrete parameters, and that is x is equal to x1, x2, and x3. And another fuzzy set is B, which is defined on a universe of discourse, and which is y1 having two elements y1 and y2. And suppose this is representing discrete temperatures, and this is going to represent pressures. And we want to find the fuzzy Cartesian product. We want to find fuzzy Cartesian product between them. Now fuzzy set A bar, not A bar, A tilde, could represent the ambient temperature. Here we are taking. And fuzzy set B tilde may represent the near optimum pressure or a certain heat exchanger, you can say. And the Cartesian product might represent the conditions of exchanger. Conditions of the exchanger. And this condition is represented in terms of temperature and pressure pairs. And these conditions are associated with efficient operations. So suppose we represent this fuzzy set as 0.2, x1, 0.5, x2, and 1, x3. So this membership function is corresponding to optimum or so here we are looking for optimum pressure, and here we were looking for ambient temperature. So this x3 is having membership value 1 as far as ambient temperature is concerned, and B is fuzzy set is like this, that y1 is not so optimum, but y2 is more optimum because its membership value is 0.9. Now this A fuzzy set can be represented as a column vector of size 3 cross 1, and B can be represented as a row vector of 1 cross 2, 2 elements here, 3 elements here. And then the fuzzy Cartesian product, which we are looking here. Fuzzy Cartesian product using the relationship which we studied earlier for fuzzy relations to represent efficient condition can be obtained in the form of a matrix. And this matrix we will be writing as A cross B, which we will call a relations matrix, and this will be corresponding to A column vector. This will be x1, x2, x3 corresponding to A, and y1, y2, and here these elements will be finding with the help of the relationship used earlier. So for example, first element, as we have studied earlier, will be minimum of these two. Using min operator we obtain. So this value will be using min operator 0.2 for pair x1 y1, x1 y1. Similarly for other pairs like x2 y1, x2 y1, we will take minimum of these two and will substitute here. So in this way we can find fuzzy relation. Thank you.